as well as organising the conference, Sumeet is also participating and presenting. Sumeet, what are you going to be talking about?
So my particular research is about employing or developing new spectroscopic methods and new imaging methodologies. Especially I'm interested in those techniques which are label free, which do not tend to modify, where we do not have to modify molecules by putting tagging fluorophores on them or any external stain on them. So we inherently look at the direct vibrations of molecules in their native state, and because those vibrations are characteristic of molecules or to the structures, then we can image such molecules or the structures related to them directly without in their native state in whatever biological matrix which is around, which we want to investigate.
So how are you doing this?
So we tend to do several things. We use laser spectroscopy, of course, but one of the prime methods in which we use in our group is called Raman spectroscopy, and various forms of Raman spectroscopy, in which actually you monitor the vibrations, the intrinsic vibrations of molecules. Basically, because a molecule is connected with bonds with different atoms, you probe those bonds. So you can probe them either with Raman spectroscopy, which is a vibrational spectroscopy, or with infrared. So we tend to do Raman more, but we also do infrared spectroscopy, but in a very easy to do way. And we also use developments in optics, like using coherent microscopy, coherent laser spectroscopy, where you use pulse lasers and ultra fast lasers to actually stimulate such vibrations, so that we can watch them in real time very quickly and get an image of a large area.
And how would you characterize the impact of this sort of imaging?
So the impact of this is great, because usually the current gold standard in a lot of diagnosis is that you have to harvest a bit of tissue or what's called a biopsy from the suspected area of abnormality, and then it's sent to a lab to do histopathological analysis. And obviously this is in itself a time-consuming and expensive process, but on the other hand, it can be really critical in things where people are actually on a surgical table, where you need that diagnosis in real time. So the techniques which we do can actually enable real-time histopathological analysis, because they not only provide instantaneous diagnosis or tell you where to look for, but they also tell you whether a certain part is diseased or healthy. So it helps surgeons and it could actually be also employed directly in a GP's clinic, where you press a button and that based on Raman spectroscopy, that instrument tells you whether something is wrong or not.
And this sounds like it will have huge clinical impact. What do you think the significance will be to the delivery of healthcare?
Yeah, I think it could have a serious and large impact, because imagine, now, for example, in tumor surgeries, if the surgeon was able to look at the tumor in real time and decide what are the with precise margins, and therefore takes out no more than what is required, then it could mean huge saving in resources, both in terms of the time which is spent, better outcomes for the patients, but also in terms of resources, because the patients, there will be less chances of recurrence for that tumor to come back, and therefore it saves money, time, everything for the NHS actually. So impact could be huge. This is one example I've stated, but in all disease cases, be it cancer, be it diabetes, it could be huge. The impact could be really, really huge.
Sumeet, thank you very much.
Welcome.